If you're looking to master the where clause in a SQL query, then you've come to the right place. Hi, I'm Charu, a technical trainer at SAS Institute. Join me on this video to learn to code the where clause in SQL through a walk in the woods, literally in the snow. But wait, what if you have no idea what SQL is all about? We have your back in this video. I'll share real weather data for January in Toronto, and we'll make super important life decisions based on weather data analysis. We'll check out answers to questions like what layers am I going to wear based on coldest days in January? Or when is it icy to help decide what boots to wear? Or when do the snow plows come out for our special four-legged boots? All this and much, much more in today's video. I'm sure you can't wait to get started. So let's dive in and check out the data. And here, before we begin any work with the data, before we try to analyze it, before we try to use the where clause in SQL, which is the entire purpose of this video, we need to first answer one of the most important questions for all data workers, which is know thy data. And how do I get to know my data? We're going to learn to get to know the data, which is a data set called January 2022 stored in the weather library. And this is a data set that I have collected by compiling together January data from reputed Canadian sources. And I'll be sure to put a link in the resource section below. So how do we ask SQL to get to know the data? SQL says, two things that are mandatory anytime you ask me questions is number one, what do you want? And number two, where do you want it from? So the what do you want is your select clause. And here we've used an asterisk to indicate we want all the columns in this data set. And where do you want it from is the from clause. We want the data to come from this data set. So we provide these two mandatory statements. These are not optional. And this allows me to get a look at the snapshot of the data. And as I execute this query, I'll see in the results that I have one row for every single date in January. And then the second column is called temp 5 p.m. Celsius. So we've captured the Celsius recording, which is how it's recorded in Canada. And later we'll show you how to convert this to Fahrenheit. And I need the temperature recording at 5 p.m. EST because that's when I head out to the dog park. And then I have other measures of temperature like the mean, the average for the day, the maximum, the minimum. An important column is wind chill. Wind chill indicates the actual blowing of the wind. How cold does it get with the wind? So you'll see, for example, on 2nd of January, the temperature at 5 p.m. was minus 7.1. The wind chill was minus 15. That's a better indicator of choices I need to make that will help me guide the actions I take based on the temperature. And that brings me to the next column. Total snow centimeters is how much snow fell. And then the next column is snow on ground in centimeters. So that's the accumulation of snow from past snowfall. So looking at this, we'll be filtering later to see how much snow fell, and based on that, make those important decisions like, well, if it's icy or if there's a lot of snow, there's blowing snow, do I have enough windshield wiper so that the visibility is clear? Can I give myself enough time? Do I really need to go to the grocery store, or can I plan and manage my groceries in a more coordinated manner? Then I have two other columns called weather and comments. So this is word text words that indicate what the weather was like. And the weather column is going to be a single word or two. And in the comments column, I might find phrases. So we'll also be filtering through that, looking for patterns of the data. For example, on this date, you see the word freezing and freezing rain or icy, deep freeze, roads covered in glass. So there are times when the entire The entire street is like a giant skating rink. And after that, if snow falls, you have like a few centimeters of snow, but under it is ice. So you need to wear the proper gear if you're walking. And then you also need to know how to walk. And if you're driving, you need to have your winter tires on. And so lots of actions will be considered based on the weather. The next question we'll attempt to answer through code is, which days did we get the most snow? This is an important question. It's going to help me make decisions about what clothing to wear, how much time to give myself to be on the road, to make choices like whether I go to the grocery store or choose not to go to the grocery store. So for this question, we're going to tackle it with the where clause. It is one of the most important clauses in a SQL query. And if you haven't used it before, you're going to start to love it. We're going to show you lots and lots of ways to get creative with the where. So let's turn and look at the code. Here then is the code to craft a SQL query using the where. You'll notice I have invoke SQL again with the PROC SQL statement. I have my select asterisk. I still want to gather all the columns from the Jan 22 table, but now I've introduced the where clause. Notice it comes after the from, so there is a syntax order we need to respect. We cannot stick the where willy-nilly anywhere. It has to be after the from, but it doesn't have to be used. What I'm trying to say here is it's not mandatory, it's optional, but if you are using it, make sure it goes after the from. So what does the where have on it? It's going to have a condition. So it's going to have a condition that'll filter the rows. I'm interested to know what days the total snow centimeters was more than 20. So a couple of things to know about the where clause. Firstly, like has to match like. If the column I'm comparing is numeric in nature, anything to the right of the expression must be a number, cannot be enclosed in quotations, or have special characters. However, if the column itself that I'm filtering is character in nature, then comparison can be with character data and must be with character data enclosed in quotations. Here, I'm curious, those dates where total snow centimeter greater than 20 will filter through the data and we'll take a quick peek to see what dates were those. And turns out it is one of the biggest dates in history in January. 17th of January went down as the most snowfall we had. I distinctly remember this day. There was almost 30 centimeters of snow. And on the ground, you had snow. There was blowing snow. It was a full blown snowstorm. Based on this, I'm going to make several decisions. Decisions such as, am I going to wear certain layers? Am I going to wear snow boots? And I know I have a lot of shoveling ahead. So lots and lots of business questions that I'm going to answer with the where clause. A next logical question is likely, how can I filter on the Fahrenheit equivalent? Up until now, we've been looking at Celsius temperatures. Now we're going to learn to build a column and then filter on that Fahrenheit column. Now, even before I begin to filter on the Fahrenheit column, I certainly need to build it. So that's what I'm going to do here in this query. A little heads up on SQL though first. On the select, SQL is going to expect from me all the columns I wish to see in the final result. So here I'm seeing columns like date, total snow centimeters, weather, temperature 5 p.m. Celsius, and in addition, I'm also going to see the new column I'm building. And that is the expression to build the Fahrenheit column by transforming the Celsius column. And on the from clause, I have the table that is providing the columns for this query. Let's go ahead and execute. And here are the results. I'll notice that for every date in January, I have a new column called temp Fahrenheit. So that's good. Now let's go and filter this column. We're ready to filter, but we need a little bit of intel about the data. I know that 45 degree Fahrenheit is cold. 20 Fahrenheit is very cold, and below that is very, very cold. So what I want to do now is filter through the Fahrenheit column and grab only those dates where the temperature in Fahrenheit was less than or equal to 20. So those super cold days. So here I've basically copied the same query as before, which built temp Fahrenheit, and then I've added the where clause, requesting only those dates where the temperature in Fahrenheit was less than or equal to 20. Does this work? Only executing will let us know. And there is an error. I noticed in the log SAS complaints, and it says, firstly, in red, the following columns were not found in the contributing tables, and it highlights the name of the column is tempf. Oops, that's the one we just built. And so we get no results. The SAS system stopped processing this step. So what do we do? Here is a workaround. We are going to use a calculated keyword on the where clause. And what the calculated keyword does, this is a SAS-ism. It goes beyond ANSI standard SQL. And it basically instructs the where clause to get the expression that built tempf and use that in the where clause. So now this query should work for us. We'll give it a spin. And lo and behold, we've got all of those dates that have a temperature rating of under or equal to 20 Fahrenheit. That's our job well done. And those are the days when I know I need to bring out the snow shovel, and there's going to be a lot of shoveling. Up until now, we've been looking at one condition only. But now we want to look at a complex condition. When is it both windy and snowing? These will help me guide the way I drive my car. I need to check if there's enough anti-freeze. I need to check if my winter tires are on. Lots and lots of actions I'll take based on this condition. But first, we'll go check out the where clause now. To answer this question of when is it windy and snowing, we introduce you to the logical operator AND. And as we mentioned before, till now we've been looking at one condition on the where, but that's not real life. Sometimes I have multiple conditions. So here is when I know it's windy and snowing, when I craft the where clause and ask for only those rows where wind chill is greater than minus 20, this is Celsius, and so this is the logical AND, total snow centimeter is greater than 0. So the way the logical operator AND works, it's going to sift through all my rows of data and only grab those rows where both these conditions are met. Let's execute and let's see what are those dates when both of these conditions were true. So here are the dates when I find both windy and snowing conditions. There's not that many rows of data. There are not that many dates here. And how does this inform my actions? I'm going to have to wear snow pants. I am going to give myself lots of time. The buffeting wind can move me and shake me. I might walk a little clumsily even. So those are the actions I would take based on the results from my where clause conditions. The previous question helped us answer the where clause conditions when we have multiple conditions. But what if I have a series of conditions and I want to pick from one? Here's question 5. When is it freezing or icy? Either of those conditions need to be true for me to get the dates returned. Again, the point of this question is to be able to address my curiosity to know what gear to wear when it's freezing or icy. So even before I get started with that, I would like to know my data. A really nice get to know your data procedure is PROC Freak. It analyzes the data and it gives me frequency tables, one-way frequency tables for these two columns, weather and comments, and I can then take a peek at those comments and then use those words to filter in my where clause. So let's give that a run first. So the words are freezing and icy, and I notice that they are in lowercase, and that's what I'm going to supply to the where clause. Earlier we saw the and in action. Now we're going to see the or, also a complex where clause. So as before, I'm selecting columns this time. I got a bit lazy. I typed in the asterisk, give me all columns from January 2022, where weather equals, and I type it in exactly the same case, like has to match like. So the data, weather is a character column. I'm comparing with character data enclosed in quotations. It has to match the same case or weather equals icy. So what is SAS going to do when we submit a SQL query as such? It is going to look for all either of those two conditions, whether the weather is icy or the weather is freezing. So we've got 3 rows of data here. 3 rows where the weather was icy or freezing. And these are the days when I'm going to have to do something really up the level of care in my gear. And I'm going to turn to my cleats so that I don't slip on the ice. And I'm also going to make sure my dog has boots. In the next segment, we're also going to see how my dog's going to practice with his boots. So we saw how we could use the or to be able to pick from either freezing or icy, to be able to pick from a couple of conditions. But I would like to type lesser code. I'm quite content to be a lazy programmer, so I'm going to turn to a special operator called the in. And what the in operator in the where clause says is give me a list of values. And it basically, the comma separating your list of values acts like an or. So I've got the word freezing, I've got the word icy. So what SQL is going to do is go sift through the January 22 dataset, look in the weather column for one of these two pieces of text. And is it going to give me the same result? Let's take a look. And indeed, we've got the exact same 3 rows of data. So your choice, you can use the in operator, or if you want to flesh it out and add the or, that's equally available. My next question is an important one. Which days have freeze in them? For this, we're going to turn to a special operator called the like, and pattern matching becomes a breeze with the like operator. All I need to do is I already know that freeze could be freezing, it could be deep freeze. So I want to get all possible variations on the string freeze. And what the like operator says is certainly happy to be used on the where clause, happy to be of service. You can apply a wildcard. The percent wildcard indicates that before the string I'm supplying, I am open to any number of characters and I'm open to any characters. And I also have a percent wildcard after because the word could be freezing. It could be deep freeze. If it's deep freeze, then the percent wildcard before helps. If it's freezing, then the percent wildcard after helps. And it's as simple as that. And here we have those words. In the comments column, we were able to locate the words freezing, rain, or deep freeze thanks to the like operator for pattern matching. This is a good operator to have handy when your data may not be pristine, clean, in the form you wish to see. For example, the data that we had. Now, what action can I take based on this? I know that when it's freezing, then the snow plows are going to come out, and right after them, the salt trucks are going to come out, which indicate mean roads that can burn paws. The dog boots need to come on. answer my very last question, we'll turn to the Boolean. I want to know how many snow days there are. Those are the days when my dog is going to burst into a smile versus the no snow days. So this is an incredible concept and we'll learn how to use it with the where clause in this segment. And before we dive into the Boolean, even before we try to understand what it's all about, let's craft a simple SQL query where we are grabbing all rows from the weather 22 dataset where total snow in centimeters is missing. And so these are all the dates when we didn't get any snow. So we know how many days, or we know this is a list of dates when I did not get any snow. That certainly gives me a little bit of insight about the data. I want to see what other ways there are to craft this where clause. So PROC SQL, I can add where total snow centimeters is missing, or I can also craft a query where I say where total snow in centimeters is now. So they all act in the same fashion. But we still haven't come to the Boolean, so let's dive into the Boolean. What is the Boolean? It is the digital computing way of transforming every instruction we give it to yeses and nos. A yes is a 1, a no is a 0. And if you think about it in real life, we actually make decisions which again boil down to a yes or a no. Is it freezing? Yes. Oh, okay, let me wear my cleats. I'm going to also stick the boots on my dog. So far, we were able to see those rows where we did not have snow. But how can I get to transform the days that had snow and have a column value of 1 when there's snow, and the column value should have a value of 0 when there's no snow? Here's how. On the select, you'll notice I have an expression called total snow centimeter greater than 0, and I've given that a column name as snow. And if total snow centimeters is missing, I called it no snow. I also grabbed the date column because I want to see what dates there was snow and no snow, so I can decide what days I do have a longer spell in the dog park. So let's execute this query. And here are the days when we had snow, and then you have the days which had no snow. So 3rd of January up until 9, there was a dry spell. And then somewhere in the middle of January, we had quite a bit of snow. So that answered my snow day versus no snow day question. How can I take the Boolean further to count the number of snow days and count the number of no snow days in January? Here's how. I'm going to take that exact same expression that I had from before, and I'm going to wrap it with the sum function. And I'm going to wrap the second column with the sum function. And what that does, it counts the number of ones for the first column and creates a single row. And again, it creates the number of ones for the second column where there was no snow and creates that one row. And here are the results. In January, we had 10 snow days and 21 no snow days. There you go. Through a romp in the snow, you learned to use the most powerful statement or clause in SQL, the where clause. Thanks for watching. Do remember to subscribe. Bye-bye.